Hello everyone. In this video we're going to talk about something called linear combinations of two vectors. And we're going to specify this with two vectors, but this works for more than two vectors as well. For most of our purposes is going to be sums of scalar multiples, which we call a linear combination of two vectors. And we're used to doing this already with the known vectors I and j. So we know that given a vector and k in 3 space, given a vector u, say, where its components are a and b, say we're just talking about a 2-space vector. Let me call that something different. Let's call that w, because we have a vector u and v pictured below. But we can rewrite this as ai plus bj using our standard basis unit vectors. And that's just a special form of a linear combination of two vectors. It's a scalar multiple of I plus a scalar multiple of j. But we don't always have to work with an orthogonal unit grid like I and j determine. We could even have what I would like to refer to as a slanted grid, as we have in the picture here. So we're going to do a couple examples just to get used to this. And the first problem says, write the following vectors as scalar multiples of u or v. All right, so I've done the first one, 0 or o to h. So o is kind of the origin for this slanted grid. And we can see that we're going 1, 2, 3 clicks in the negative direction along that slanted grid, which is parallel to u. So it's going to be negative 3u in this example. All right, now let's do the next one, h to I. So we're going to go 1, 2 steps along the slanted grid. That's the vector connecting the points h to the point I, and that's going opposite the vector v, and it's double the length. So negative 2v would be that vector. A to g, we're going 2 units, all right, opposite the vector u. So this will be negative 2u. B to k, we're going 1, 2, 3, 4, 5, 6. So we're taking the vector v and going 6 steps in the opposite direction. So negative 6 times the vector v. All right, and the last one, f to d, what are we doing there? We're also going in the opposite direction. Let's do one, let's just go the opposite way. Let's go d to f. All right, in this example, this time it's going 1, 2, 3, 4, 5. All right, so that's 5 times the length of the vector v. So d to f in this picture would be 5v. All right, I'm going to erase this, and then we're going to do the next example, which is dealing with linear combinations, which are sums of scalar multiples of u and v. All right, so moving on to that example, again, we're talking about a linear combination of u and v, which we call which is defined as a sum of scalar multiples of u and v. So the vectors we're going to be writing down now are going to be a multiple, I'll say c1 times u, plus another multiple, say c2 times the vector v. All right, now let's look at these. We want to go from the point O. We want to write down the vector in terms of u and v as a linear combination of u and v that connects the point O to the point E. All right, so let's draw that right on here. All right, so we want to go from O to E, but we can't go straight from O to E. We need to follow this slanted grid. All right, so one way to get there would be to go along the U, the grid parallel to U, 3 steps in the U direction, and then 3 steps in the V direction. So we would have to take the sum of 3U and 3V for this example. So the vector connecting those two together, let's draw those in red. From this vector is 3U. This vector is 3V. If I add them together, I get the blue pictured above from going from O to E. All right, so that's our result there. Let's do a couple more of these and then you can get the picture. So it's just 3U plus 3V. Okay. I'm just going to quickly pause the video and then I'm going to take a picture of this and move it down. Okay, never mind. I'm just going to leave that there. Let's do another couple up here. If I need to erase up here, I'll do that. So going from O to J. All right, how are we going to get from O to J? So this time we want to go from O to j. Again, we can either go this direction or this direction. It will end up at the same spot. All right, now let's just write down what those two vectors are. So we have to go 1, 2, 3, 4 clicks in the negative v direction, so negative 4v. All right, notice this vector over here is also negative 4v, and then 1, 2 in the negative u direction, so this vector is negative 2u, so is this vector. All right, so we're looking at negative 2u plus 4v for that example, for that next example. And this is going to be related to something we're going to do in the next video. All right, so let's take a look at just a couple more of these ones here. The next one was going from G to L. Let's take a look at that one, and then maybe we'll leave it at that. So in here, we want to go straight from the point G to the point L. All right, we want to know what's the vector connecting G to L. Well, we can see in here, we're going one step in the U direction, so that's just one U, or just U. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, looks like 9 in the opposite direction of V, so that'll be negative 9u. All right, so the next one listed on here, the vector connecting G to L in the picture would be negative 1u, or just negative u, plus or minus 9v. Okay, so I hope you get the idea there about what we call linear combination, which is an important concept, sums of scalar multiples of u and v. Let's just go back up to the picture real quick to finish this video off. Hopefully you follow that we don't just have to get to points along the grid. We could get to a point in the middle of one of these grid boxes also. So for instance, what if I wanted to write down that point right there, or the vector that we would get by connecting the origin O to that point? Well, you can see we're going to have to, in this case, go a fractional amount, possibly, of the vector u. It's maybe a little bit more than 1. Okay, and then a little bit more than 1 scalar multiple, scalar multiple of v, which is magnitude more than 1. We're not just going one click, we're going kind of between 1 and 2 clicks. So for instance, that vector right there, which I've labeled in red, would have some scalar multiple of u, right? So it's non-integer scalar multiple of u, and a non-integer scalar multiple of v. All right, and we add those two together, we would get the coordinates of that point relative to that coordinate axis. Okay, so that's it for this video.